Sometime in 1978, a foreign locomotive arrived under restricted protocol at Union Pacific's Cheyenne Yard. Not British, not Canadian. Soviet. A TEP70 diesel-electric, built behind the Iron Curtain, whose factory specifications on paper suggested it could pull more than the legendary American Big Boy. The most powerful railroad in the country had quietly agreed to test a machine from the other side of the Cold War. What their engineers found, and why that locomotive was shipped home before the year was out, begins with understanding just how much Union Pacific had at stake. Union Pacific, by the late 1970s, stood as the undisputed heavyweight of American railroading. No other railroad moved more freight, pulled heavier trains, or ran longer tonnage across the continent. The company's name was synonymous with industrial might, its yellow locomotives crossing deserts, mountains, and plains from the Midwest to the Pacific. For decades, Union Pacific set the standard other railroads chased. Their engineering teams demanded not just power, but reliability, fuel efficiency, and the ability to endure punishing schedules across thousands of miles. Nowhere was this pride more visible than in their roster of legendary locomotives. The Big Boy, a steam giant with a 4884 wheel arrangement built in the 1940s, remained a symbol of the brute force that made Union Pacific famous. Weighing over 600 tons fully loaded, the Big Boy could haul freight trains up the steep grades of Sherman Hill without a helper, delivering up to 135,000 pounds of tractive effort. Even after steam faded, the Big Boy's legend endured, immortalized in photographs, posters, and the memories of railroaders who called it the King of the Rails. By 1978, Union Pacific's transition to diesel power was complete, but the company's reputation for pushing the limits had only grown. Their engineers scrutinized every new locomotive, demanding performance that matched the railroad's massive scale. When it came to evaluating new motive power, Union Pacific measured everything against its own high bar. Haulage records, ton miles, and fuel consumption logs were not just statistics, they were proof of supremacy. In trade journals and industry gatherings, Union Pacific's standards became the unofficial benchmark for what a locomotive should be. This culture of excellence made the arrival of a foreign challenger not just a technical curiosity, but a matter of institutional pride. For Union Pacific, any locomotive invited onto its rails was not just being tested, it was being measured against the best in the world. The Big Boy's legacy and the railroad's own reputation set the stage for a rare and secretive confrontation between East and West, numbers and reality. In the heart of the Soviet Union, ambition took the shape of steel and diesel at the Kolomna Locomotive Works. The early 1970s brought a directive from the Ministry of Railways: design a locomotive that could pull the longest passenger trains across Russia's endless distances, at speeds that would leave older models behind. Viktor Sergeyev, lead designer at Kolomna, answered the call. His team's brief was clear: deliver unrivaled power, reliability in brutal winters, and the flexibility to run anywhere from the forests of Siberia to the crowded corridors around Moscow. The result was the TEP70. On paper, it was a revelation. The factory spec sheet boasted a continuous power output of 4 megawatts, over 5,300 horsepower, fed by a V12 turbocharged diesel engine. Traction motors on all 6 axles delivered a maximum tractive effort of 300 kilonewtons, enough to muscle a full express up a 1% grade at speed. Despite its muscle, the TEP70 kept its axle load to just 20 tons, a figure chosen to protect the fragile Soviet track network from the kind of pounding inflicted by heavier Western engines. The locomotive stretched nearly 25 meters end to end, its frame braced for the long hauls and harsh conditions that defined Soviet railroading. Sergeyev's design team published these numbers in technical journals and factory brochures, presenting the TEP70 as a new benchmark for Soviet engineering. The locomotive's AC generator and DC traction motors, laid out in modular blocks, promised easier servicing and upgrades. Maintenance manuals prescribed a strict schedule, daily inspections, oil changes every 500 hours, and a full overhaul at 2,500. The dual-circuit electrical system, with protective relays guarding against overloads, was advanced for the time. On test runs between Moscow and St. Petersburg, the prototype hit 130 kilometers per hour under load, confirming much of what the spec sheet claimed. Soviet officials, eager to demonstrate parity with Western technology, made sure these achievements were recorded and distributed through official channels. But for all the numbers and the confidence behind them, the TEP70's reputation rested on the promise that it could compete with, or even surpass, the best the West had to offer. In the context of Cold War rivalry, these claims were more than technical boasts. They were statements of national pride and an invitation to compare, measure, and challenge. A direct comparison between the Soviet TEP70 and Union Pacific's legendary Big Boy reads like a provocation. The Big Boy, built to dominate the steepest grades of the American West, delivered around 4.6 megawatts of peak power and a tractive effort of 602 kilonewtons. Its reputation was forged not only in numbers, but in decades of hauling freight over Sherman Hill, setting records that still echo through railroading circles. Yet the TP70's factory sheet, stamped in Kolomna and translated for Western eyes, claimed 4 megawatts of continuous power and a maximum tractive effort of 300 kilonewtons. On paper, the Soviet locomotive was no mere curiosity. It was a machine that appeared, at least numerically, to stand in the same league as the Big Boy. The difference lay in the details. The TEP70's axle load, just 20 tons, was nearly a third lighter per axle than its American rival. Its 6 powered axles, modular alternating current generator, and direct current traction motors suggested a level of engineering sophistication that demanded attention. For Union Pacific's engineers, used to the brawn of American diesels and the legacy of steam giants, the numbers raised uncomfortable questions. Could a Soviet passenger locomotive really outpull the Big Boy, even if only on a spec sheet? Inside Union Pacific's Omaha headquarters, the debate was not just technical, it was personal. Bob Heller, the company's chief mechanical engineer, reviewed the translated Soviet tables and found himself caught between skepticism and professional curiosity. In a memo dated spring 1978, Heller summarized the stakes. If the TEP70's drawbar pull approaches our own records, we owe it to ourselves to see the evidence firsthand. The memo was both a challenge and a safeguard, a call to test the Soviet claims under American conditions, with Union Pacific's own standards as the yardstick. Heller's signature set the process in motion. The decision was clear. The TEP70 would be brought onto Union Pacific rails, not as a diplomatic gesture, but as a technical trial. The numbers alone were too provocative to ignore. Only a real-world test could settle the question that now hung over the engineering division. Could Soviet design truly rival the best of the West, or would the difference between paper and practice prove decisive? In 1978, the Cheyenne Yard logbook recorded a single cryptic entry: an unusual diesel received with restricted access. No manufacturer, no serial number, just a brief directive handle per special protocol. Among pages of routine arrivals, this lone line hints at something out of the ordinary entering Union Pacific's territory. The TP70's arrival left almost no paper trail. Union Pacific's Cold War-era procedures for foreign equipment were strict, but even by those standards, documentation is scarce. Customs filings and internal logs typically accompanied any non-standard locomotive, yet for this Soviet import, nothing beyond the yard note survives. Maritime records from 1978 list only a generic foreign diesel locomotive weighing 120 tons, omitting serials and country of origin. The lack of detail is striking, suggesting the locomotive was treated as a confidential guest rather than a new asset. The Cheyenne Yard reference to restricted protocol was reserved for equipment under direct oversight by senior engineering staff. Distribution lists for such arrivals were tightly controlled, and logs kept separate from routine maintenance records. This deliberate minimization of exposure was standard for sensitive equipment in the 1970s, ensuring that even within Union Pacific, few would know of its presence. The single surviving log entry, paired with the absence of customs or photographic evidence, grounds the story in fact. The TEP70's arrival, though nearly invisible, is anchored in Union Pacific's own records. Union Pacific's engineering team approached the TEP70 with a mixture of skepticism and curiosity. The locomotive sat in the yard, its sharp-edged bodywork and angular cab standing out against the rounded forms of American diesels. Inspectors circled the machine, notebooks in hand, studying every detail. The first thing that drew attention was the sheer heft of the undercarriage. Bearings on each axle were massive, designed for long intervals between service, much heavier than their American counterparts. Grease fittings and lubrication points were marked with Cyrillic stencils, some still showing traces of red factory paint from Colomna. At the steps, the cab door swung open with a metallic clank, revealing a space that felt Spartan by Western standards. The control stand was simple, rows of toggle switches lined up beside a chunky throttle lever, all labeled in Russian. There was no air conditioning, only a small fan bolted to the wall and thick layers of insulation lining the ceiling. A battered thermos and a faded Soviet railway badge sat on the instrument shelf, reminders of the locomotive's origins. Engineers checked the electrical cabinets, finding a maze of heavy-gauge wiring and robust circuit breakers. The traction motor leads were thick, routed through steel conduits rather than flexible cable trays. Protective relays were installed in duplicate, a nod to the Soviet preference for redundancy. Every access panel was secured with oversized bolts, suggesting a design philosophy shaped by harsh winters and rough track, where durability mattered more than convenience. The walk-around left a clear impression. This was a locomotive built for survival, not comfort. Its raw strength was evident in every weld and casting, but the simplicity of the controls and the utilitarian finish hinted at a different set of priorities than those found on American rails. The test began before dawn, under a veil of secrecy that matched the Cold War mood. Union Pacific's dynamometer car, a rolling laboratory packed with analog gauges and chart recorders, was coupled directly behind the TEP70. Engineers calibrated every sensor, drawbar pull, speed, fuel flow, and wheel slip, cross-checking readings against a checklist written in both English and Russian. The procedure was exact: a rated load hill start, followed by a sustained pull at increasing speed, all data logged in real time. The goal was simple but unforgiving: capture the locomotive's true tractive effort curve, not just what the Soviet factory had claimed. At the heart of the process stood senior test engineer Carla Delgado. Her signature, dated June 8, 1978, appears at the bottom of the original dynamometer printout, certifying the integrity of the data. The test protocol required the TEP70 to start a 2,800-ton train from a dead stop on a 1% grade, then hold maximum effort for a full mile. As the throttle advanced, the dynamometer's inked needle traced a sharp climb, peaking at 1,720 kilonewtons before dropping off, evidence of the turbocharger reaching its thermal limit. The printout, time-stamped to the minute, captured the entire curve: a steep rise, a plateau, then a sudden decline as the system overheated. No interpretation was offered in the moment. The numbers spoke for themselves, locked in black and red lines across the chart. Delgado's initials, scrawled beside the curve, made the result official. The test had delivered a clear, empirical foundation, one that would soon be measured against the legends of American railroading and the realities of daily operation. On the test track, the TEP70 delivered moments that turned heads, even among Union Pacific's seasoned engineers. The locomotive's starting tractive effort, measured at over 320 kilonewtons, allowed it to move a 2,800-ton consist from a dead stop on a 1% grade, an achievement that matched or slightly exceeded the initial pull of some American heavy freight units. The inked trace on the dynamometer chart climbed sharply in those first seconds, peaking before the turbocharger's thermal ceiling was reached. In that narrow window, the Soviet diesel's raw force was undeniable. High-altitude runs, conducted in the thin air outside Cheyenne, revealed another surprise. The TEP70's V12 turbocharged engine, designed for Siberian winters and the long, flat stretches between Russian cities, actually produced a slight horsepower boost in the cooler, less oxygen-rich air. The test logs recorded a continuous output that edged about 3% above the design rating. For a locomotive built half a world away, this was not just impressive, it was a technical curiosity that challenged assumptions about Soviet engineering. Inspectors noted the locomotive's modular traction system, with 6 powered axles and redundant protective relays. The alternating current generator and direct current traction motors worked in concert, delivering a smooth transfer of power to the rails. Maintenance protocols, though unfamiliar, prescribed frequent checks and robust lubrication, hinting at an underlying philosophy of durability through simplicity. In those best-case moments, the TEP70 demonstrated a kind of brute competence, able to pull hard, start heavy, and maintain its footing where lesser machines might have slipped. For a brief span, the numbers on the chart and the reality on the rails seemed to align. The Soviet Challenger had shown it could meet, and in certain respects surpass, the benchmarks set by Union Pacific's own giants. But as the data piled up, it became clear that these peaks were only part of the story. The first signs of trouble came sooner than Union Pacific's engineers expected. During extended load tests, the TEP70's turbocharger ran well above its design temperature, with thermal sensors logging repeated spikes into the danger zone. At just over 250 kilometers of sustained operation, the engine's crankcase developed a hairline crack, traced by inspectors to thermal cycling and stress concentrations around the main bearing saddles. The failure was not catastrophic, but it was enough to halt the test and prompt a full teardown. Engineers noted that the Soviet alloy used in the crankcase casting did not match the fatigue resistance of American standards, making field repairs both slow and uncertain. The problems did not end there. Traction motor cutouts became a recurring headache as the locomotive's direct current motors tripped their protective relays under heavy load. Each incident forced a stop to reset the system, disrupting the test schedule and creating a backlog of maintenance logs. Union Pacific's shop crews, trained on EMD and GE diesels, found themselves stymied by unfamiliar wiring layouts and Cyrillic-labeled schematics. Even routine tasks, like changing out a failed relay or sourcing a replacement turbo blade, became logistical puzzles. There were no domestic spares. Every critical component had to be ordered from the Soviet Union, with lead times stretching into months. The TEP70's maintenance manuals prescribed procedures and intervals that did not align with Union Pacific's established practices, further complicating matters. A final evaluation report compiled by the engineering division painted a stark picture. The locomotive spent nearly 12% of its runtime sidelined for unscheduled repairs, a figure far above Union Pacific's operational threshold. The supply chain simply could not support the TEP70's needs. Without a pipeline for parts or a trained cadre of mechanics, even the most impressive specs faded into irrelevance. The experiment revealed a hard truth. Technical brilliance on paper meant little without the infrastructure and ecosystem to sustain it. What began as a test of power ended as a lesson in the realities of industrial integration. On October 31st, 1978, a single memo closed the chapter on Union Pacific's experiment with the Soviet TEP70. Issued from the Office of the Vice President of Mechanical Operations, the document carried a plain but final directive. The locomotive was to be returned to its Soviet supplier. The order cited excessive downtime, persistent maintenance delays, and a lack of compliance with American emissions standards. The language was formal, stripped of any hint of disappointment or surprise. It referenced the official test logs, a tally of unscheduled repairs, and an instruction to coordinate shipment with the original exporter. The return to vendor order did not linger on the TEP70's moments of technical promise or the curiosity it had sparked among Union Pacific's engineers. Instead, it focused on the hard arithmetic of reliability and logistics. The locomotive had spent more than 1 out of every 8 hours sidelined for repairs, a figure well above the railroad's operational threshold. Replacement parts had to be sourced from the USSR, each request entangled in months of paperwork and customs clearance. The memo's closing lines authorized the use of a West Coast port for outbound shipping. It specified that the locomotive be crated and loaded under direct supervision, with all documentation sealed for internal review only. No ceremony accompanied the decision. The TEP70 was quietly prepared for departure, its brief American journey ending not with fanfare but with a signature and a stamped date. The experiment was over. What remained was a stack of engineering reports, a handful of restricted memos, and a lesson on the difference between headline numbers and real-world integration. Even now, the TEP70's brief American trial echoes in today's race for technological dominance. It's not just raw power or bold claims that shape the future, it's the hidden web of standards, support, and real-world resilience. As industries push for breakthroughs, the lesson endures. Engineering glory is measured not on paper, but on the rails that carry the weight. What matters is what endures. Thanks for watching.